Okay, hello again. Now, last couple of days we've been working with trigonometric ratios, and specifically, we were talking about the tangent ratio. And just as a review, I hope you remember that the tangent of a right triangle is the ratio of the two legs. All right. So remember, if we have a right triangle that looks like this, all right, if we have a right triangle that looks like this, and I tell you that this is A, and this is B, and this is C, all right? And if I say that this angle here is angle A, all right, well, we learned that the tangent of angle A equals the ratio, means one over the other, two numbers on top of each other. The ratio is going to be the opposite leg on top, which is A, and the adjacent leg, right? The adjacent leg here on bottom. So the tangent of A is A over B, all right? So we have already learned that. That's the tangent ratio. Now today we're going to learn the two other primary, the most important, the most used trigonometric ratios. So these three so we've already learned one, the tangent. We're going to learn two more today. And these three altogether, they are the most used trigonometric ratios. You have to know them, all right? And you're going to use them the rest of this year, next year, your junior year, your 11th grade year, and your 12th grade year. You're going to use it all the time, all right? Very useful. All right, so let's start off with the sine. All right, S-I-N-E, the sine. Now, the tangent is the ratio of the two legs. The sine is the ratio of one of the legs to the hypotenuse. All right, which leg? Well, the opposite leg. All right. So the sine is the ratio of the opposite leg, which is A for this one, and the hypotenuse, which is C. So the sine of angle A, and it's spelled S-I-N-E, sine, but when we write it short, we just write S-I-N, all right? Just like with tangent, we write T-A-N. For sine, we just write S-I-N. So the sine of angle A is going to be the opposite leg, which is A, over the hypotenuse, which is C. Remember, the hypotenuse is always the side that is opposite the right angle. Here's our right angle. So if we draw an arrow over here, it's C, all right? Okay, so the sine of angle A is A over C. Now we can write the definition of sine. All right, so what is a sine? A sine is the ratio of the opposite leg to the hypotenuse. All right, of a right triangle. This is for right triangles, all right? So the opposite leg to the hypotenuse, so A over C. That is the sine, all right? So you need to know that. All right, and then the final one is called the cosine. So we're going to have the tangent, the sine, and the cosine. Now, again, just like with the tangent and sine, we write it short. When we write it short, we just write the first three letters. So it's C-O-S, all right? That means cosine, all right, of angle A, all right? This angle right here. Now, how do we find the cosine? Well, remember, the tangent is the two legs, the opposite leg over the adjacent leg, so A over B. The sine is the opposite leg over the hypotenuse, which is A over C. Now, the cosine is the adjacent leg, which is B, over the hypotenuse, which is C. So the cosine is going to be B over C. Okay? So these are the three important trigonometric functions that we're going to talk about. Let me write down the definition now for cosine. So what is the definition for cosine? Well, the sine is the ratio of the opposite leg to the hypotenuse of a right triangle. The cosine is the ratio of the adjacent leg to the hypotenuse of a right triangle. Okay? So the ratio of the adjacent leg, which is B, it's next to A, right? Here's A. So A is, the little a is the opposite side, and little b is the adjacent leg, right? It's right next to it. Okay. So you need to know sine, cosine, tangent. Now, there is a trick, a little phrase or word that you can remember that will help you to remember which one is which, all right? So remember this. I'm going to write it right here, all right? It's SOH C. Oops, I just messed up. Hold on. Oh, no, it did the whole thing. SOH CAH and then TOA. And we say SOHCAHTOA. All right? So a lot of times when you are learning mathematics, your teacher in your class will often have you say this over and over. There's even a little song that you can find on YouTube, SOHCAHTOA. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. You have to keep saying it over and remember it, all right? And remember, so is S-O-H, all right? So it's sine. This means sine, all right? Sine is the opposite, opposite over hypotenuse, H-O-H, all right? And then C, which is the cosine, all right, is the adjacent over the hypotenuse, all right? So B over C, all right? And then TOA, all right? TOA, well, T is the tangent, all right? Tangent, wait, yeah, tangent, and it's the opposite over the adjacent, all right? So SOHCAHTOA, sine, cosine, tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. All right, so you need to remember those. Sine, cosine, tangent. You have to remember which one is which. Okay? So this picture down here is just telling us that same thing. So the sine is the length of the leg opposite over the hypotenuse, all right? The opposite over the hypotenuse. So, S-O-H, so, all right? And then the cosine is the adjacent over the hypotenuse. So that's ka, C-A-H, ka, so, ka. And then we also know tangent is the opposite over adjacent leg. Okay, so remember those. All right, let's go on and then look at a few examples of how we can use this, all right? Don't worry about this one yet. We'll talk about that next time. Let's just look at a few examples. So here we have, in exercises 1 through 3, we need to find the sine of f, the sine of g, and then the cosine of f, and then the cosine of g. And we need to write each answer as a fraction and as a decimal rounded to 4 places. All right, so we'll have to use our calculators, all right, to write the decimals out. All right, actually, I'll use my phone calculator because it's right here. All right, so Let me get my phone calculator out. Sorry. All right, so let's first do f. Let's find the sine of f and the cosine of f. So here is f, right? Here is f, all right? And we want to first find what is the sine of f, all right? Well, the sine, remember, so is the sine is the opposite over the adjacent, OH. Opposite is going to be over here, right? And then the hypotenuse is the long one. It's opposite the right angle. Here's our right angle. And what is opposite? Is 13. So the sine of f is going to be 12 over 13. All right, 12 over 13. Now, for this one, I'll go ahead and find the decimal point. All right, but I'm not going to do that for all of them because I don't want to waste your time with me punching numbers into a calculator. All right. It's 0.9231. All right, they said 4 places, so we want 0.9231. All right, so that's the answer for sine of f. Now, let's also find the cosine of f. All right, the cosine of f, so COSF. All right. Now, the cosine of f is going to be, what is it? So, ka is CAH. Cosine is AH, which is the adjacent. All right. So, here's f. Adjacent leg is this leg, which is 5. And then AH. So, H is the hypotenuse, which is 13. All right. So, it's going to be 5 over 13. So, we're going to write that. So it's going to be 5 over 13. And then you should also use your calculator to find what is the 4 decimal points of this. I'm not going to do that because it just wastes time. All right, so we have sine of f and cosine of f. Now it also wants us to find the sine of g. All right, sine of g. So again, here's G, all right. Actually, I'll do it in, let me take that off. Let me do it in a different color. All right, let's do it in green. All right, so here's G, and then we want to find the sine. Remember, so is, sine is the OH, opposite over hypotenuse. So the opposite here is going to be this side, right? Which is 5. All right, 5. And then the hypotenuse is still the same. It's 13. All right, still here. So it's going to be 5 over 13. All right, which, again, we can find the decimal point for it too. All right. And then finally, we want to find the the cosine of G. All right, let's find the cosine of G. Well, here's G. Cosine, so we have ka is AH. All right, CAH. Ka. Cosine is AH, which is the adjacent over hypotenuse. Adjacent to G here is going to be this side, 12. And the hypotenuse is still 13, so it's going to be 12 over 13. All right. 12 over 13. And that's going to equal, and we already actually found that right here, 0.9231. All right. So these are all of our answers. 1, 2, 3, 4 answers. Now, notice something. You will see here that the cosine of f is 5 over 13. And the sine of G is 5 over 13, right? These are the same, all right? And we see that the sine of f is 12 over 13, and the cosine of G is 12 over 13. These are the same, all right? And this is always going to be the way it is, all right? These are always going to, the sine of one acute angle of a right triangle is going to equal the cosine of the other acute angle of the right triangle, and vice versa, all right? So this is always going to be the case, all right? And that's actually what this is saying right here, the sine and cosine of complementary angles. So what are complementary angles? Remember, complementary angles are angles that add to 90 degrees. This angle plus this angle will always equal 90 degrees, right? Because this one is 90 degrees, and all three have to equal 180. So that means this plus this will always equal 90 degrees. And this is telling us that the sine of an angle, let's pretend this is 30 degrees, all right? Let's say A is 30 degrees. Well, it's telling us that's going to equal 90, the cosine of 90 minus 30, which is 60, all right? So the sine of 30 equals the cosine of 60, all right? That's always true, and that's going to be true for all of these, all right? So we're going to have to find this one, and we're going to also want to find this one, the cosine, and the cosine of this angle is going to equal the sine of this angle. And the cosine of this angle is going to equal the sine of this angle, all right? That's just the way it is. All right, so let's go ahead and finish these up, all right? Let's do the sine of f, all right, for this one, for number 2. The sine of f, remember, sine, so opposite over hypotenuse, all right? So opposite is over here, 65. The hypotenuse is this side, 97. So sine of f is going to equal 65 over 97. Okay? And you should also find the 4 decimal points of this, but I'm not going to do that now. All right, next, let's find the cosine of f. Well, the cosine is going to be the, remember, so cosine is AH, adjacent over hypotenuse. So the adjacent here is 72, and the hypotenuse is 97. Okay, good. And then we also need to find the sine of G, which is over here, and the cosine of G. Okay? But we don't even have to look at the triangle again. We can just look at our answers over here, because remember, we just said that the sine of one acute angle is going to equal the cosine of the other. So this has to equal 72 over 97. And this cosine of G has to equal the 65 over 97. Okay, we're done with that one. All right, you also need to find the decimal points. In your homework, you will need to find the decimal points. All right. Okay, and let's look at this last one. Now, this one is actually pretty easy because we should already know what angles these are. All right? Do we know what angles these are? We do, because this is a special triangle. We already learned this. If this side and this side are equal, all right, if they are the same, then this means that must be a 90, 45, 45. So 45, 45, 90 angle, a triangle. So we actually know that this is 45 degrees, but let's just write F for now, all right? It's actually 45. F equals 45. But what is it going to be? Well, remember, the sign is so, opposite over hypotenuse, OH. All right, so it's square root of 2 is the opposite, and 2 is the hypotenuse. So it's square root of 2 over 2. All right? And then let's do the cosine of f. Well, let's see. The adjacent now is this one, which is a square root of 2. So adjacent over hypotenuse, which is 2. Oh, they're the same, all right? Because the opposite and the adjacent leg are both the square root of 2 here. So that means our sine and our cosine are going to equal the same thing, which means that for angle G over here, cosine, and oh, I put cosine. Oops, I should have put sine on top, but it doesn't matter. All right, they're all going to be the cosine of the sine of f and the cosine of g. They're going to be the same, square root of 2 over 2, and these two are going to be the same, square root of 2 over 2. All right, so we're done. We found all of those. All right, now the last part, it says write the expression in terms of cosine. So right now they gave us sine of 9 degrees. We want to say the sine of 9 degrees equals the cosine of what? Well, we just said up here, we said that the 90 degrees minus the angle is always going to equal the sine. So cosine of 90 degrees minus this is going to equal the sine of that. So we can just use 90 degrees minus this, all right? So what is 90 minus 9? 81. So the sine of 9 degrees equals the cosine of 81 degrees. Make sure you put a degree sign here. I will take off points on a quiz if you don't have degree sign. All right. Next, sine of 30 degrees. All right, what is the sine of 30 degrees? Well, it's going to equal the cosine of what? 90 minus 30, which is 60 degrees. All right, so the sine of 30 degrees equals the cosine of 60 degrees. And then finally, here we have the sine of 77 degrees. Well, that's going to equal the cosine of 90 minus 77, which is 13. So it's going to be cosine of 13 degrees. And that's it. We're done. All right, so that's everything that we're going to talk about for today. I will give you guys homework assignments to practice finding the sine and the cosine, all right, and also to use this trick, all right, where the sine of x degrees equals the cosine of 90 minus x degrees. All right, so remember that. Sine of x equals the cosine of 90 minus x. All right. All right, and that's degrees. All right. And it's the same way backwards. All right, so if we write cosine of x degrees equals the sine of 90 minus x. This is also true. All right, so remember this. All right, that's everything. See you guys next time.